All right, today's first note is going to talk about cubic functions. Cubic functions. And they name these functions by the power that the function is taken to. In this case, this function is taken to the third power, much like the quadratic function was taken to the second power. You should know that there is a standard form for a cubic function. We'll be using this sometimes. All right. There's your standard form for a cubic function. And we always have a parent graph, and a parent graph is the most simplest form, the simplest form of the function. It is y equals x cubed. And that's generally the one you start with. So we're going to explore the cubic function. Here's something we could point out really quick. And it's a mistake people make. If I used that parent function and plugged in a -2, you have to get rid of the notion that you just can put a -2 in and keep going. You must put it in parentheses, because this says right here, take your input and cube it. Well, my input is -2, and if I cube -2, that's -2 times -2 times -2. Well, in this situation, it's good practice to do this, but -2 times -2 times -2 is -8. So I guess we realize that 3 negatives, when multiplied together, are going to come up to a negative. Alright, so if I do this, this is going to give me a -8. -1 times -1 times -1 is going to give me a -1. 0 times 0 times 0 is going to give me 0. 1 times 1 times 1 is going to give me 1, and 2 times 2 times 2 is going to give me 8 again. So if we do this, we're going to get a graph. There's -2, -8. -1, -1, 0, 1, 1, and 2, 8. Continued on forever. Let's see if we can there's a little wiggle in the middle right there. We get a graph that looks like that. So I'm not going to do too much on here. I'm going to do some of these problems down here, and I'm just going to highlight the rest for you to do. Domain and range. Well, my domain, it really does keep going left, although in a much smaller rate at which it's going up and down. So my domain is still -infinity as it goes left forever, positive infinity as it does go right forever. Range, I go down and up forever. Once again, that's -infinity to infinity. Remember, we have hard ends and soft ends, and we're using parentheses here, not bracket. And behavior, well, as x goes to -infinity, as x goes left, y goes down. Y goes to -infinity, and as x goes to positive infinity, y goes to positive infinity. I'm going to do every other one of these. So here's a 0. My 0 is right here. That's your x-intercept, or your solution. So my 0, there's only one in this case, on this one, 0, 0. And the values for which the function is positive, well, that would be everything off in this direction. Alright, so it looks like it starts just after 0, so soft ending on 0, all the way up to infinity. I would like you to do the value for which it's negative. Value for increasing. Well, it looks like it's always going up left to right. Always going up left to right. So it's increasing from -infinity to positive infinity. And I would like you to do decreasing. Alright. Now, it's asking if it is an even or an odd function. So let's go ahead and test this out. Let's see if these are the same. So we'll test for an even. So it says, is the function of -x equal to the function of x? Well, let's look at our function. Our function is x squared. That's what the output is. Well, this says if the output, when I plug in -x, Oh, I'm sorry, it's x cubed. Alright. Here we go. I think I should be putting them in parentheses here. And I'm going to move the paper up a little bit to see it. So what if I plug in a negative x cubed right there, and here I plug in just, forget the f, x cubed. Well, those are in fact not the same thing. This negative x cubed is still negative x cubed, and this is x cubed. Not with the other one. Is it an odd function? So this says if I plug in the opposite of my input, is it the same as if I take the opposite of my output? So let's look at this function. Alright. So my input is x. So if I plug in a negative x cubed, it's important how we write this, is it the same as taking my output, x cubed, and making that the opposite? Is that the same? There's my output, and now I make that output the opposite. And in this case, negative x cubed is exactly the same as negative x cubed. And we're seeing something we kind of know. It's an odd function. And remember, when we were talking about odd functions, they generally have an odd number as an exponent. And there it is. That's the end of the first movie.